All right, ladies and gentlemen. So we're going to continue to shine some light on 3I Atlas because now that I've covered in the first video the details that we need to cover about the differences Tesla and Einstein had in how they believed the universe worked, and the fact that we pretty much went with Einstein's opinion on this. And the problem is, each of their theories completely ignores the other. One says gravity is a really weak force and has nothing to do with how the universe operates, which is technically not true, even though gravity is a weak and local force. Now, that's the trick. It's a local force, but it can actually be very strong, and we can demonstrate that too. But it is a local force, local to that body. Outside of that body, gravity stops applying, and there are other forces that are applying. And that has been the trick, to find out where the limits of gravity really are, because it's all been theoretical up until 2017. And this is where people don't understand why, when we've been watching the stars for thousands of years, why all of a sudden now do we act like it's the first time this kind of object has passed by? Well, we don't know. What we do know is this is the first time these have happened where we were in a position to see it and know that this is what's happening empirically, scientifically, because we saw it. Okay, normally we just see them when they're really close. Now we have things orbiting Mars and the moon and other planets, and those things are assets farther out in the solar system. And they can see and tell us, like Voyager, what's coming, because they can see them. And all of a sudden we get a signal. Oh, look at that. Voyager says something's out there. Oh, shit, it's coming this way. Well, it's proved very useful. And I got to tell you, when Voyager's dead, in fact, long before it is, we should fire a follow-up and another probe right along its path, because it's proved so useful. And going way faster, so that we can slingshot it around a few planets and make it get out there as fast as humanly possible, so we can cover the distance from here to where it basically dies as quickly as humanly possible, so it can continue the journey of exploration, baby. So in this video, we're going to talk about what this means, that this has come through, and whether or not it's a spaceship, because there are a lot of people saying it's a spaceship. There are a lot of people saying it's not. NASA's shutting up. Now, in the history, they've proven that they will shut up when it's not a spaceship and everybody's saying it is, because they don't want to argue with you until they can prove it empirically. Scientists are like that. We want to know. Now, I wouldn't have put out a video, except I'm pretty sure I already know because of all the information I've been able to pick up so far. Let's review. First things first. As it came in fairly close to Mars. Now, gravity, when Einstein first penned his theories on it, it is a local force, but he expanded it later to suggest that it is a much larger force. All right, well, the simple reality is that's not necessarily untrue, that it is a powerful force. Now, here's the problem. Einstein and Tesla were arguing back and forth that there was clearly more going on than this technically weak local force that we call gravity. And he's right. Now, Einstein recognized this, but he insisted that it had to be, of course, more gravity. Well, that wasn't true. But he didn't really want to admit Tesla was right either, because that would dismantle his theory on gravity, which was technically true, and he knew it. And he knew he couldn't account for all of it, but he knew that gravity was real, so he just stuck with that. Tesla also knew electromagnetism was real, and that it was extraordinarily powerful, and that it had to have an effect. And he was right. And that it had to be the majority of effect. Well, he may be right on that. In fact, the problem is our model says that Einstein's right, but the practical reality we're seeing from these objects that pass through, guys, is not that. That's why they're surprising some of our science as to how they travel. Because as soon as they come in, we see a massive object that, according to the laws of gravity, should directly interact, only it doesn't. It passed right through Mars' gravity field, what so-called gravity field, only it's not. And we didn't study the electromagnetism enough to know whether it would have an electromagnetic field big enough to reach out that far. We don't know. What we do see is that this object is passed by. And it's massive enough that and Mars is massive enough where the gravity should have interacted, if it's as powerful as Einstein said later in his life. Well, we can now pretty much prove that that's not true. It is a weak local force. What we can also show here is that Mars has a much weaker electromagnetic field than Earth does. But let's review that. Earth has a molten electromagnetic core that is comprised of very magnetic materials. We have this thing called lodestone. You can look it up. It is the world's strongest natural magnet, and we have it in many places on Earth, including right here where I live in Ottawa, Canada. That has been a problem for some of the builders locally, and I know because I counseled with one local construction company and helped them overcome a problem they were having building in a spot because they had girders in a building being pulled out of place as the building was being constructed, and they couldn't figure out why. There was no flaw in the building. They were building on stone. And yet, this pole was so strong that it was ripping the girders out of the base of the building. And it turned out right next door, they had a really big shot of lodestone in the property they were going to build on. And that's what was drawing this out. It was actually in the spot they were going to put their parking lot. And it meant they had to dig way deeper than they wanted. But once they got it out, it was worth way more money than the parking lot cost to build. So they were pretty happy because they were already paying penalties for the project being slowed down big time, 100 grand a day or some crazy shit like that. And it had gone on for months. It was costing them millions and millions of dollars delaying this building. So they were pretty happy to, I didn't charge them anything. I just knew enough about the area and about the science to know that this was the problem. And that they had chosen an area that the city founders actually specifically designated as nobody should ever build here because of lodestone. Turns out those old bastards knew their shit. Now here's the problem. That was stuff that they could empirically test. And when it comes to that kind of stuff, the old folks, they really knew their stuff. But when it comes to stuff out in space, they really had no way to empirically test it. And this is where we get to it. Now, since 2017, we've had enough assets of enough variety in place. From deep scanning objects to viewing objects, very different thing. Taking a light reading, very different thing. Doing spectroscopy, we can do that on objects that are close by. That's a lot more than just viewing it through a telescope, guys. One is just taking a picture. The other one is bouncing light off it and seeing how that light responds. And that's totally different. The other, penetrating it with x-rays and that kind of a deep penetrating type thing and scanning it, infrared, all these different things we can now look at to determine what this object is and what it's comprised of. We can also look at it a lot closer up and see more detail. Now, with all these things combined, we do see a lot of things. For example, we can look back at the trajectory it's come in on and see some things. One, we do see it is tumbling very slowly, very, very slowly. But we do know that objects over time, regardless of what their speed was to start with, it will eventually slow down. Now, in space, there's nothing directly to slow it down, but we know this can't be infinite because the laws of mathematics say that it won't be, that eventually it'll slow down. Now, these guys are having a trouble explaining why its rotation is slower, but its speed is faster. And I'll tell you this, as it passes through solar systems and does interfere with gravity and magnetic fields, it will get faster, as we have seen it do coming through ours. But it didn't happen at Mars. It was already getting faster. It's our sun. It is a super strong electromagnet, and anything with any kind of pull at all is being yanked towards it on a beeline for it, but not straight at it because the electromagnetic field isn't actually in the center of it. It's around it. Don't forget that. You wonder why things get pulled past it. This is why, because they have both attraction and repulsion. And if the attraction isn't strong enough to overcome the repulsion, it just goes by. Because just like Tesla's experiment in 1910, he had an experiment where he had put into a sphere a whole bunch of other little spheres in the shape of the planets that were relative to the right shapes and sizes of the planets. And he had made a working model of the solar system that ran only electromagnetically, and it worked. And this is how I believe the universe actually operates. Now, this is what he believed, and it was a very controversial thing at the time. But because this object is much older, whatever its initial rotation was when it broke off of its initial piece and the initial explosion or whatever that knocked it loose, well, it's been tumbling ever since then. And we can prove now that that's billions of years old because of how far away it came from. And it has interacted with some solar systems, but not close enough to be really doing much but speed up a little bit, which accounts for its speed. You want to know why it's rotating so slowly and the other objects weren't? Well, they were younger. And the math, the logic, says they should be rotating more slowly because it hasn't hit anything else to speed up that rotation. It's done nothing but cruise for 1 billion years. Okay, well, that means it's done nothing but have time to slow that rotation. And over time, that should smooth out. And it should theoretically be, if an object has traveled along its path without interference from the time of its ejection, it should theoretically slow down over time, but very slowly. So incredibly incrementally slowly, because it's in space and there's nothing interfering with it to slow it down, that it's immeasurable without observing it over millions of years. That's my guess. And that because this object has probably been traveling for millions of years, we are now seeing the result of that in terms of its slow, stable rotation. That would explain it. As to why the pulses are so steady, well, that explains the pulses of light that are so steady, because if part of it is gem and it's broken, that's exactly what you'd see as the light passes from the stars. It would be shiny and reflective, very reflective in some spots, with all the dust and other things coming off it. They're detecting bits of nickel now and some iron and other things. That's normal because it's a meteorite. It's a big chunk of a planet. Now, here's the thing. As it passes through, what we're seeing is it didn't interfere with Mars much. It didn't gain any speed from that, but it's gaining speed steady as it comes through, pulled towards the sun. The sun traditionally is the thing you would slingshot around if you wanted to go faster, because in any solar system, it is the heart, man. It is the beating heart. And when you look at what a sun is, this big plasmatic ball of gas, it's not a rocky body. It's not really that heavy for its size. And our sun would have started out much smaller. Did you know the sun is actually expanding? I've studied the sun and light. And in fact, that's how I came to study the sun, because I was studying light. I have a degree in photonics. So I thought I really needed to do a video on this, because I do understand a lot of the principles involved, and I do have honorary degrees in several areas that apply to this, including mathematics. And I realized when Avi Loeb went through the math and looked at its path, I realized it couldn't possibly be a spaceship for 3 reasons right away. First, if I was to design a probe, any of us that design a spaceship, the last thing we want is it losing physical mass. That means it's broken and leaking. If this is a spaceship, it's the worst one ever. Second, it's traveling and towards the sun, and it's outgassing from the front. That means there was a pocket of something that could be heated on the front that didn't need a lot of temperature to start to evaporate. Could have been trapped as smoke already, or could have just been something that was locked in ice. But in either case, they're saying, well, it's not close enough to get that hot, but we have radiation, and there are elements that react to more to the radiation than they will to the physical temperature anyway, especially internally to this object. And our sun is actually towards the ends of its life right now, putting out some really hot radiation. And it's in the middle of solar flaring all the time and really freaking out right now, which means there's more radiation coming from it right now than there usually would be. I can't believe I have to explain this to physicists, but I don't. NASA understands this. Mikio Kaku understands this. There's a lot of people who understand these things, and you're not hearing them say it has to be a spaceship. Avi Loeb said the last one was a spaceship, guys. And it wasn't. As far as we could tell, it wasn't. It just wasn't. For one, if it was tumbling too erratically. It didn't do any of the things that a spaceship would do. This one is coming in on the right trajectory where it could see all the right things. It's coming by Mars and could see all our rovers. It's coming by all our places where we have stuff. It seems to be coming through all the planets in just the right way to suggest that it might be doing it on purpose to see all our shit. That's a pretty paranoid attitude. The reality is it went through at least 2 other solar systems, and we can prove that, only it didn't really interact with them, which means it's not very magnetic. And that's only proven as it did the same with Mars, because it's not very magnetic, but it is being pulled. And it has been headed this way. And it has been increasing in speed since before it got influenced by our sun. Which means it's been on an increasing trajectory. There may be currents in space where regions of space have weaker pull or maybe a negative pull, and this object is positively charged and it gets pushed out of that area. And that may be possible, whereas our area is positively charged. And it may be why we're actually getting closer to the star system next to us, Andromeda, which means we may be both positively charged, and the universe is pulling us together as a result. We're also getting farther from the other. We're pushing away, and it's pushing away from us, which means it may be negatively charged, and we may be literally opposite and pushing away. That is my actual functional theory of how the universe works, guys. So I'm going to end this one here, but I wanted to cover the rest of the details as to how I know empirically this is not a spaceship. One, if we design a spaceship that's going to lose its physical material for millions of years, that's bad. If we're going to hollow this out, we would have worked on it and there wouldn't be loose dust particles on the surface. It would be machined. That's not what we're seeing here. What we're seeing here is that there's a whole bunch of loose crap on it that's coming off. The very fact that we're seeing that means it's not a spaceship. Because in the millions of years it's traveled, we can tell it hasn't gone through anything that would have accounted for all this dust and debris. What we can see is that it hasn't been close enough to another sun like ours that's strong, to have a strong solar wind, to have that be blown off. It hasn't been close enough to a heat source to have things that could melt. This is its first time in that time that it's been accounting for that. Everything in our solar system is not like that. It's been on near our sun its whole life. Which is why it's cool when we see things from deep space, because this shit's interesting. So it comes through. Only it's not actually thrusting itself, as far as we can tell. There's all kinds of things that could be going on here that would all of it can be accounted for with electromagnetism, solar wind, and the outgassing simply by the fact that if it is a chunk of a planet and there's something on the front, well, that's the point facing the sun, guys. That's the point heating up. And you're surprised there's outgassing from it? Hell no. It was speeding up. If we're positively charged and it's positively charged and it's sucking us toward it, and then all of a sudden it hits the brakes because it gets outgassing, which is what's going to happen. And the solar wind is actually providing resistance, as we already know and can prove. So it slows down. And then you go, oh my God, it's a spaceship. No. If it was a spaceship, it would have pulled into orbit around Mars at least once because it saw technology there. And we were looking at it. It didn't even bother. It blew on by like it was nothing. Like it didn't know. And did its thing. Kept on its path. Doesn't seem to be very affected by anything except that it wants to make a run around our sun. Which is what is natural. It's why we're all orbiting around it, guys. So, as it progresses, we will find out more about it. But the real trick is to fill in our blanks and understand how much of it is electromagnetism that we're seeing and how much of it is gravity and where the two meet, and really working out the balance of those two theories so that we can accurately predict these things in the future. That is what we're working on. The problem is you guys all freak out about aliens, even some of the smartest people. And the next thing you know, it's a bullshit show. And NASA goes, you know what? We're not even having this conversation with you. And that's a problem, guys. And this is why they shut up about this kind of stuff every time. But it's not been aliens yet. In fact, when it is aliens, they show you the footage.